So let's make a tennis game in MFC. Let's make a game of tennis. Okay. Single document. Game of tennis. Hey, here we go. Single document. Tennis game. Tick frame. Like that. No need for printing. Also no need for those. Finished. Dun 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 dun. Okay, okay. Put it in place nicely. It's looking good. Yeah, I think it looks good now. Okey dokies. Let's start creating a game of tennis. I want to play tennis. I wanna play tennis, and my tennis ball is here. My tennis ball is here. Okay. Right. Just preparing this thing. Take some time to prepare this thing, but it will come. It will come. So there we go. Okie dokie. So let us start. Okie dokies. Let's do the basics first. Okay, so let's look at this is a view program, view window, build. Let's see how it looks now. Let us see how it looks now. Oh, there it goes. Yeah, so we want to have a tennis game over here. Let us start. Okie dokies. So the first thing we need here is that we need to get, because there's a flickering happening here. Actually, oh, I can actually solve that problem. So let's draw the tennis ball first. So we need to create an image object. We need to read the image. Well, we're gonna use this one. We're gonna use this image, and I have 8 of them. I'm gonna rotate that. I'm gonna rotate that ball. So I'm gonna make the animation. I have 8 balls, 8 of these balls, and I'm gonna rotate them. They are actually here. Yeps, so here is the first ball, right? There's the second ball, 22 degrees, then there's the 45 degrees, and so on. So I'm gonna animate that ball. So, okay, we need to read that ball first, so I'm gonna I'll just start testing this thing. So we need to have, no, we don't need to have that. MFC has that class here automatically. Sorry, private C image. I just call it ball. Ball image. How about that? Sounds like a good name. And now we need to go and draw that. Here's the draw function. Let's try to draw the ball. It's quite simple actually. You just say draw. And here you're gonna put, yeah, you need to put, we need to read the ball first. We need to load the ball first. So I could do it, for example, I can do it in a construction function, why not? So load, let's load the ball. Right, yeah, so I need to put the file name there. So, but before I need to copy the balls in this project, so I'm gonna copy the balls. We need these 8 balls. I'm gonna copy that, all the angles. Excuse me. All the angles, 8 balls. I'm gonna place them into the project folder, which is here. So I'm gonna say, is it just paste? I just copied them, right? Yeah, there they are. Right, so let's just take the first ball now. That one. We need to have a good way to load them, but I'm just testing first. And now it's loaded in the image, and now we can probably draw that ball over there. So it's gonna be, we need to pass this guy. We need to pass the get save HD, the device context. We need to pass the device context into the image class, and then I can say there are 7 different ways to draw it. I'm gonna use the destination. I'm gonna put here 30. Let me put 20. Then we put width. Now we can decide how big the ball is. Let me put 100. That's the size of the ball. We can make it smaller. I make it a little bit smaller than than it is. Actually, let me just first draw it as it is. I first draw it the size as it is in a file. And yeah, that will draw that actually. It's that simple. C++ is simple. There it is, my ball. My ball is there. My nice ball, my nice ball. But the ball is too big. The ball is too big. Now, let me move that ball just for fun. Just for fun. So let me do a function here which is moving that. I'm gonna just quickly create a test function. When I'm moving the mouse, I will move the ball. Just for fun. Just for fun. So we need to have the mouse move message. Where's the mouse move message? Here. Okay, and we need to have the position changer. I'm gonna add here just a ball position, like a position of the. This is just testing. I'm gonna delete this. So we start from position is like 1, and we're gonna use that variable now to place that ball. I'm gonna put it here 1, 1, 1, and now I'm gonna increase that ball here in a mouse move. I'm gonna increase that ball by 1. So, and then I'm gonna say I'm gonna update the invalidate update. I'm gonna redraw the whole window. Let's see what happens. There we go. But you can see that there's a flickering happening. It's flickering badly. That's what I'm saying. It's flickering. I'll put it there. Yeah, you can see it flickering. Not good. The flickering is because the background is always drawing with the white. Then you throw the ball, then you throw the white again. Then you throw because the background is white. That's why it's flickering, because it keeps drawing the background and it keeps doing that. So we don't want to do that. We want to draw the whole picture on a screen, on a one go. We need to draw everything first, and then we need to put that picture there, like a paper. We need to draw on a paper and put the paper on there. So we need to change the logic here. We don't want to draw first the ball and then draw the line, and we want to draw everything first and then put the final drawing there as it is. To do that, we need to do a trick here. We need to go and download nice class, flickering prevention class, which helps us to do that. So I'm gonna go here and say C++ MFC flicker free. There's a nice code here. Somebody made it 20 years ago. 20 years ago. So just go here and follow the instructions. I'm just gonna copy this code from here. Oh, there's a copy code here. Copied. Aha, it's copied now. And now I'm gonna create maybe I create a new file here. New item, header file. Mem flicker mem dc flicker free device context. How about that kind of name? Flicker free device context. I don't know how to call it, but it's very long. So let's put it there. So I'm gonna just paste that code here. And like that. So thanks to this author key to rule, thank you very much. Thank you for creating this code. And now it's not recognizing the CDC. Why is that? It's because I need to call that PHP. I think I need to call this PHP, the framework thing. Include PCH. It's missing there, isn't it? So is this Pragma once gonna help here? Don't remember actually. It's not recognizing that. Pragma ones is not helping here. Yeah, but we can use Pragma ones, but this one needs MFC library, so I need to say here include PCH. Actually PCH like this. Okay, yeah, there you go. Now it works. I'm gonna change this name to flicker free. Free DC device contacts. Flicker free device contacts. Like that. Okay, so that's it. So now if I go now and include this one, and then use it like it's instructed here, they say that this is how we use it. And we also need to do this erase background. We need to put it false, this one. So I'm gonna do that now. On erase background. So we need on erase background. On erase background. Erase background. That's the one. So instead of calling it, we need to call we need to return false. And now it's easy to change. The only thing we need to do here is that we need to go here and create that object here, and I call it DC, and we need to initialize it by the device context of this. Yeah, actually that one. Okay. So we're gonna use this instead, this one. And now we can say get easy, get safe. What is it? Why is it not liking that? I need to, sorry, yeah, like that, yeah. Put the pointer, just a pointer. So now if I draw it now, it should be flicker free now. You see, there's no flickering anymore. Yeah, so yes, there's no flickering anymore. Next thing I need to have is the ball. So I start creating now the objects. I think the ball needs to be a class. The ball needs to be a class. Before I do that, yeah, it needs to be a class. So I'm gonna just I'm gonna keep it simple, but I'm gonna create the ball. Create a class, ball, and okay. Ball goes there. So this is one ball. So public, private. Okie dokie. So this ball is going to have the image. I think so. It's going to have the image. Yeah. If I keep it simple like that, I'm gonna put that image. image there. It's not the best way to do it in a professional setting, but this is a simple game, so I'm just gonna put it there for now. Normally we don't draw the object in the same class, but I think I'm gonna do it this time. Okie dokie, so the image is there. Sorry, but I was thinking also to keep it a little bit more simple, that I'm gonna create a, you know, the object class, like moving object or something like that. Let me try that. I'm gonna create another parent class for this, which is called moving object. Does it compile now? Yeah. So, yeps. Okay, I'm gonna now create another class, and let's call moving object. Any moving object, like that. And this one obviously has public, private, and then it has a position or rectangle. Which one is better? I think position. Everything, each of them has a position. Yeah. So I'm gonna use C point. I think I'm using C point because this is MFC Programming. So C point position M position. Right. And we will see later what we need here. So I'm gonna now say that the ball is inherited from that include moving object. So I'm gonna inherit this public moving object to make it more simple in a way. So that, yeah. And now we can say here that update, when we need to update the position of this ball. So I'm going to create update function. Update, and then we need another function which can be called render. When we are rendering, then obviously we are rendering using the now this is a good question. Yeah, we need to use the flicker free thing, because we are using the flicker free drawing. So I'm going to include the flicker free here. So I'm going to use that flicker free device context to draw that thing. Okie dokie. And this is updating the position and stuff like that. And now this one needs to be in a parent class also. And moving object virtual. We can do polymorphism here, that we are calling that. And here I'm gonna say override. Yeah, because we are overriding it from the from the parent class. Okis dokis. So, and here we can also have the render. We need to have the render as a virtual. We're gonna call the parent class here, like that. Okis dokis. So, right. Okay, moving up, and then we need the direction, right? Direction vector. It's actually, that's an interesting question. Are we gonna use direction? That's the thing that it needs to move. It's gonna be speed and direction vector. Let me think about that. Am I gonna change? because we can separate them. We can have a direction vector which is length 1, and then we can have a speed, another one. Many times people combine them, but let me think which one is better. We could have that as a unique vector. If we have a unique vector, the speed is always 1. Then we can separate the speed from the distance for the direction. Direction is a different thing. I kind of like that idea. But then we need to do some mathematical calculations. 2. Make it 1. Which one is better? A unique vector. Speed, separating the speed from the I think they need to be separated. Maybe float speed. We start from 0, speed 0, and then we have a direction. I can call it. I can use it to C point. No, I can't. Maybe I create a struct here. Direction. Because it needs to be floats. Actually doubles. Direction. Just X and Y actually. X and Y. That's the direction we're going. So I'm gonna call it direction. And the direction initial value could be well, I think we need the function for the direction. Yep. It's an interesting question. I'm still thinking about it. The direction thing. If I'm turning. If I'm turning. Yeah, we could do that. Let me create a function here called set direction. And then we're gonna basically pass the direction there, new direction. And then let's implement that direction function here. So it's gonna be moving objects, and now this direction always needs to have a direction vector always has length 1. It needs to be 1 because the speed is telling what is the speed. The direction vector never tells the speed. I'm using this value to tell the speed. I'm kind of separating them. I'm still thinking, is it a good... We could obviously combine them. Okay, let me separate them. Let's do this route this time. So I need to include that flicker free also there. Can I forward declare that class? I think I can. Okay, so now let's look at the how we need to make it. This needs to be always 1. The length needs to be length like that. So this needs to be always 1. So let's see how we do it. First we copy that new direction, but the new direction length is not 1 necessarily, so we need to modify it. So it will be, I think it's divided by now I'm gonna Google, my memory is not the best. How to make unit vector. I kind of remembered. Oh, unit vectors. Okay, so unit vector is, why is there no formula here? I think it's this one. Divided by the length of the length of the vector. I think it's that one. Yeah, it's the vector divided by the length of the vector. Okay, so it's not super difficult, so I'm gonna say here so unit vector x divided by this one multiplied by this one. Actually, I'm gonna say float. I'm gonna say double. Vector new vector length equals to this one. Plus the y's and I think it's square root of that is the length, so that's the length of the new vector. And now we just need to divide this x divided, so yeah, so direction x equals to the new vector x divided by the length, and the direction y equals the new vector divided by the new length. Okay, that be const. Okay, so now this vector is always has length 1. The vector always has length 1. Okay, that's done. Node makes the, we don't need to actually set a node. It's actually node only changes not the speed. Doesn't change the speed. So this one doesn't change the speed. Okis dokis. Okay, let's continue. Let us continue. Right. Now we need to create this image. We need to load the image. I'm thinking, let's try to do it in a construction function, if it's possible. It's always nice to do it there, so const, maybe C-string. String. And right. Right. So const SDI string image file name. Okay, and then we're gonna implement the constructor here. Ball. And now we can load the ball. We can load the ball. And the code is here. So we can do that one over there. Like that. And then we can say load the ball. Aha, this load is asking C string, so I need to actually change this to C string. C string makes life easier because the C image is using C string, so I'm gonna use that same there. Like that, and then in the ball, that's how we call it. And now it's easy to implement the render function. Well, there might be a couple of issues here. Let's see how we render the ball. So it says render. Okay, so where is the position of the ball? That's a good question. So the position is stored in the upper class moving object. So here is the direction, here is the position. Okay, so that's now the we will just take the current position, current direction. Current position. So we can create a getter here, get position. So I'm returning the C point, get position. Let's just return that. Just return that. That's all we need here, kind of. Yeah, get the position, return position. Yeah, like that. And now okay, get position. We need to get position. And what else we need? We need to create a size. The ball needs a size, right? So what if I just use the C size? Because we're using MFC, so C size, ball size, and let's initialize that size in a constructor. Right. ball size, and gonna put there. Okay, const, and then ball size. Copy that ball size into the member variable. Yips. Okay, so that's the size we're gonna use, and now we need to render the ball. Now it should be piece of cake, because we only need to say now that image draw, and then we need to say that get save HTC, and then we're gonna, so now the placement, the place of the ball, well, the place of the ball will be it's get position, and the get position we will get that from here. So maybe I just call const reference. There's also const. Just call the get position here. Auto position, and just const auto. How about that? No copy. So it's gonna be position X. Position, that's integer. Yeah, that's integer. Position X and position Y. And now the size of the ball. Well, that will be easy. It will be from here. The size is already here. So we just say here now that size CX, size CY. Yeah, there you go. And semicolon. Now I want to test this ball now. I want to test this ball. It draws that. It's good to test test a little bit. So let me test the ball. Is it gonna draw it? It should draw it in a 0, 0. The reason being because okay, so the position is not initialized, by the way. So what is the position at the moment? The position is nowhere. Update. That's an interesting question. Do we need to initialize this one? What do you think? I think the position needs to be initialized always, kind of. So that's why I'm gonna do that here. Let's try to do it from here. Do I need to put it at the beginning or at the end? Ball size, ball position, where do I put that? Maybe at the end. Ball position, yeah. Okay. And now actually this upper class needs to have the same thing. It needs to have the constructor here. Finally. So we need to at least set the position at the beginning. So const position. Right. And now I'm gonna implement this constructor for the position. So it's gonna be simply M position takes that thing over there. So hello everybody. Okie dokie. Right, so we will store the position. That's done. And next we need to use that position over there. Over there. Okay, so let's do that. So yeah, the position is now set, and ball, yeah, the ball needs to now, we need to implement that position in the ball. So I'm gonna say here that const m bossy position, like that. And now oh, not like that. No, it doesn't have the position in the parent class. The parent class has the position, so let us change that. I need to call the parent class constructor here at the beginning. Oi, I don't like that. Doesn't look so good. We remove that first. What if I do it now? Put it there. Like that. And then we need to put that position into that constructor. Like that. So we're calling the parent class constructor, passing the position to the parent class, and store it there. Okie dokie. Yeah, that's done. So let's now create the ball object and test this thing. So I'm gonna include the ball. Include the ball somehow, somewhere. Yeah, I think I can do it in a view here. So instead of the image, I'm gonna create the ball here. Okay, I'm gonna create a ball and just gonna call it ball, and then I'm gonna initialize it straight away. File name is this one. Position, let's say position 170. That's a good position. Size is, sorry, that's size. Sorry, that's size. Better just put those things so I know what they are. That's size and that's position. Position is that, so that's the position. This is the size. So the size will be, say, 100 size. Okie dokie. And now let me use this ball. So I'm not gonna do this. I remove this old version and move it. I'm not gonna throw the old ball. So let's throw this ball. So I say render, and I pass the device context into the renderer, Let's try this thing. Oh, there's one error. Render, what does it say? Already has the body. Already has a body. I know why that happens, because I had body here. There's a body here, so I take the body from the H file. Okay, and now is the time of the truth, moment of the truth, I mean. Yeah, it's there, the ball is there. Yeah, the ball is there. Yeah. Now, let's move that ball. Oi. Yeah, because I did not change the position of the ball, it didn't move. Okie dokie. Yeah, let's not worry about it. It definitely works. I mean, so let me now change that the update works. So in update, we're gonna move the ball. The update moves the ball, the render draws the ball. So, so update changes the position and render draws that ball. So let us change the position, and yeah, we need to have a function here called set position. Set position, new position of the ball, and the position will be C point. Actually the ball needs to move itself, isn't it? Well, we can have both. We can have the set position and move. Yeah, we kind of need both of them, isn't it? Sometimes we need to change the position of the ball by forcefully. So I'm gonna do this position as well, although we're not really using that. So it's gonna be the new position like that. Okay. Const. Yeah. But what we really want here is we don't want the set position, we want to move, isn't it? Oh, no, the ball moves automatically, isn't it? Yeah. When we call update, the ball needs to move. Yeah. What am I doing? I'm not thinking. When we say that move, because the ball knows the speed, the ball knows the direction, we just say that move yourself, right? That's why I made all of these. Okay, so it needs to go to update. When I say update, it will move this direction this much. Okay, so I'm gonna now implement this update. Sorry. Just thinking that do we need to consider the time here? It really needs to move according to the time, isn't it? I think we need to consider the time, isn't it? I think it's not too difficult to do that. Yeah, I think we need to just elapsed time. Yeah, let's use the time. We need to be real, so depending how much time we need to move, we will move that much. So I'm gonna change this. So if we have 1 second time, we need to move 1 second amount of distance. So I'm gonna do that. So it should not be too difficult to implement that. So let's go here and say update. And and now the thing is that the parent class now needs to do the update, because the parent class knows the speed and the direction, so we need to actually implement the parent class version as well. So I'm gonna implement that here. That's gonna do the moving. So I should double actually here. Double, why not? Let's use double instead. Could be const double actually. Const double. Like that. Oh, of course. Const double elapsed time. Oh, I don't need to put the const there. Okay, so now I'm gonna put that same thing here. What am I doing? To go, I was supposed to go here. Yeah. Update, ball update, update. Okay, that's done. And also override here. This one also override. We are overriding that renderer. So yeah. So now let's go and implement this. This is the important part here. So if we have 1 second, and this is the speed per second. Let's say this is the speed per, is this speed per second? I think it's speed per second. Yeah, speed pixels per second. Okay, so that's the speed. Pixels per second. Pixels per, how many pixels per second? So okay, so now the distance. I'm a mathematician, but I don't remember these things. So how many kilometers per second? How many kilometers? So distance divided by like how many kilometers per hour. Distance per time equals the speed, right? Okay, so this is the formula, right? How many kilometers, like car, 80 kilometers per hour. That's the speed, right? So we know the time, which is this one, and we know the speed. We need to know the distance, right? It's not rocket science. We need to multiply by time, isn't it? So that implies that the distance equals to speed multiplied by time. Okay. So, and we want this distance. That's what we want. We want the distance here. We want to know how long we need to move. How far away we need to move. So distance equals to elapsed time multiplied by the speed. Speed multiplied by the elapsed time. Okay. Okay, so that's the distance. And now this is the direction. If this is the direction, this is the speed, what is the position? That's a good question. Well, it will be the direction vector. Okay, oh, maybe I need to write it here. It's the new position will be, it will be the old position, which is this one. Oh, just old position plus the unit vector multiplied by the distance. Yeah, just like that. Yeah, unit vector multiplied by distance. It's that simple. Yes, it's that simple. That will be the new position. Yeah. And remember that the direction might have changed, but it's all automatic now here. Anyway, it's gonna be the direction vector. Okay. Direction vector unit vector multiplied by the distance. Yeah, so that's the new position. It's the old position plus the direction vector, which is a unit vector, which is also a unique vector, which is unit vector multiplied by the distance. So that means we need to do x and y differently. So we need to say x equals to old position, which is position x, this one, same, old position, plus direction vector. Okay, so direction vector is here. X multiplied by the distance. Okay, and then the y will be the same. We just say y equals the position y, direction y, and distance. Yeah, that's it. Done. That will be the new position, and now we can use that new position. Okay. Right, so much mathematics. This should be a piece of cake. I studied mathematics in the university, so I should know these things. Okay, so right, so let's just, we need to initialize. The direction has not been initialized, by the way, so we need to initialize the direction, by the way. Yeah, that's missing from here. When we create the object, we need to initialize that as well. There's no way around that. Okay, so we need to force the initialization of this direction. So in the version. Yep, and now say m direction vector equals to, like that. Okay, so now we have the direction also. Well, the only problem is that, okay, I'm gonna put assert here because direction, it's not allowed that the direction is 0. Okay, it's not allowed. For example, this direction is not allowed. We can't allow that. So we have to deal with the error. We have to check the direction here, I think so. So to do error check for the direction x or y cannot be 0. Cannot be 0. Okay, I might do that later fully perfectly. I'm just gonna do assert here for now. Just gonna assert here. See assert. I'm just gonna assert here false in a debug mode. Gonna just assert false here if so that it crashes here in debug version if that's done. Okay. Oh no, not like that. I need to check that actually. So bool no I can say if direction x, but the direction x that's a float double. I can't check the 0. Okay, so I have to take absolute value. I can't check. Okay, but I'm gonna check that anyway. If direction x, I need to take absolute value. I have no choice here. If the absolute value of this one is less than some epsilon, we put here, I don't know what is 0. So this is 0 or near 0. Maybe like that. So let's say this is 0. This is almost 0. So if the direction is less than this one, then we think that it's 0. We can't calculate the or the y is less than that. In that case, we need to there's an error, and we can't really continue because the distance has bad value. Okay, that's done. So now the direction needs to be passed also into the ball size, position and direction. Okay, direction, and goes here. And now we are passing the direction there, isn't it? We are passing it to the parent class. Okay, and now it's kind of working. So if we call update here, elapsed time, okay. I did so much coding, so it's interesting to see how it works. The speed. Am I setting the speed? I'm not setting the speed. By the way, I need to do that also here. Setting the speed. Yeah, I'm not setting the speed. So I need to do one more thing. We need to set the speed. Why did I put float? I put double. Yeah, I better put double. So okay, speed and speed. Const and yeah, now we need to pass the speed as well. Also from the ball we need to pass the speed, I think. Yeah, one more here. Remove the const from here and speed const, and then forwarding the speed to the parent class. Okay, now we have a speed as well. I'm gonna put speed like 10. When I'm testing, I'm gonna put speed 10. Let's see how it works. So here I need to say, okay, so that's the direction. Okay, so direction will be, let's just say 1 1. That was, direction is a float. Double, okay. So put 1.0. So it's going 45 degrees. 45 degrees to the 45 degrees down. What is the T macro? It means Unicode string. Because you have a ASCII string, and then Unicode string, Chinese letters. Unicode string is Chinese letters. And then the speed, let's put here speed like 5.0. Okay, so now this is interesting. Yeah. I'm kind of done this now. But the thing is that when I'm running it, what happens? Let's see. Interesting, is it gonna work now? Let me build. There's a mistake there. Operation. Position. Yeah, because why did I put const there? Set position. Build again. Oh, build succeeded quite well, isn't it? I did a lot of code without errors. There's a couple of warnings, but I don't care about the warnings. Oh, that warning I might care. Double the long. Course. That is actually interesting. Oh yeah, I know what this happens. I will fix that. Wait a minute, distance. Yeah. Yeah, okay. So I fixed that now. Static cast. Okay. I first run it. I fix that later. I first run that ball. The ball needs to go down now. Wow. So let me call that now. So mouse move. We don't need the position anymore. I'm just gonna call that ball update, and I need to pass the time. I need to pass the time here. Well, what is the time? That's a good question. So I need to check the time here, isn't it? What if I just put, okay, I don't need to put the real time. I'm just gonna put fake time here. Let's say the time is like 0.5 seconds or 0.3. So let's say the time is always 0.5 seconds when we come here. It's not really, but actually 0.1 because I'm moving the mouse a lot. Okay, so we update like that, and then we draw. Gosh, I'm scared. Ball, render ball. Let's see what happens. I think it might work. I did so much good. It can't work. Can't possibly work. I'm waiting for crash now. It didn't crash, but it doesn't move. So now let's let me go and check why it doesn't move. When I'm moving the mouse, it should go down. But it's easy to the good thing is that this is easy to debug. So it didn't work straight away. So why it doesn't work? Okay, I'm gonna check that. It's very easy to debug. I'm gonna put a dot here, and let me see what's wrong. What's wrong? Okay, so now I'm gonna go inside the function. Okay. Oh, because I'm not calling the, oh yeah, I know because I'm not doing anything in the update here. I need to call the parent class version. I forgot to do that. I need to call the parent class update from here. Okay, I forgot to put that one. Okay, let me run it now. Yeah, so when the ball is updating, it just calls the parent class update, which is moving the object. So still not working. Okay, so I'm gonna debug again. F11. Okay, F11. So let's see what happens here. So here is it should move now. So the distance is the speed. What is the speed? The speed is correct. Elapsed time is correct. So the distance is, yeah, so the distance is 0.5 pixels. That's the problem, isn't it? Yeah, 0.5 pixels. So it thinks 0 because it goes down. It goes to 0, isn't it? Yeah, that's the problem here. It goes everything else. Okay, the direction vector. Oh, there's another problem here. The direction vector length should be 1. I forgot to call that. The direction vector should be 1. So set direction. I need to call the set direction function here. Yeah, here. We can't just set it like that. We need to call that function here. So I'm gonna remove that. I'm gonna call the set direction because the set direction is gonna make it unit vector. So okay, that's the right way. But we still have the problem because it's moving 0.5 pixels. So so that's 0. How do I fix that? Because if it's 0.5 pixels, that will be rounded to 0 pixels. Aha, I think I know what I need to do. Yeah, I know. The position should not be integer. It should be float also. So that it can, even if it's 0.1 pixels, it still counts. It can't be integer because 0 point something always goes to 0. It needs to be float. I see. Yeah, this is wrong. This position should be float. Yeah, I made a mistake here. So I'm gonna just create a new variable, new class here, which is called position. Okay. Well, it's the same as direction, but who cares? And now I'm gonna use the position instead. Yeah. And now I need to go everywhere and change it. How do I easily change that? No, I just need to go every file now. Every file. Yeah. So cpos. cPoint. Yeah. I made a mistake there, by the way. Gosh. Yeah, I need to change only the points. I need to change all the points to position. Okay. Set position, yeah. Get position. Yeah, okay. Then from here. Okay. Then the ball. And then the CPP ball. Okay. Okay. And now if I go to view, yeah, here I need to use the position instead. It's a 100.0, 170.0. Okay, actually now it might work. Now it might work because now it's taking decimal numbers. They are not rounded. Okay. It doesn't move much, but there are some errors. Yes. Syntax error. Yeah. Yeah, there you go. Da 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 da. Give me thumbs up. Yeah. There you go. The ball is moving. Let me do it again. Da 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 da. The ball is moving. Okie dokie, so good. It works. So now let's make the ball. Okay, so next thing I want to do is the timer. I need to create a timer. I need to put a timer for the game so that there's a timer constantly hitting, you know, the next step. So I'm gonna put the timer running. So let's go here. Timer function. And let's run this is the game loop. Yeah, there you go. So I'm gonna do update here. Okay. So and so the update kind of goes there. Okay, and now we need to pass the time elapsed, the new time there. Let me Google about that. C++ accurate time. No, not this one. Yeah, this one. High resolution clock. Okay. So this is the way you do it. So we need to take the chrono. So in order to do that, I need to include the chrono library here. Chrono, and then gonna use this thing from here. Just check what is the type of that. It's a chrono steady clock point. STD chrono steady clock time point. Gosh, chrono steady clock time point. Okay. Chrono steady clock time point. Whatever that is, I need to put that here. Chrono STD chrono steady clock time point. Yeah, time point. Okay, so that will be the current time passed. How do you call it? Time passed. Total time. I don't know, total time. How do I call that? It's called last time, previous time. Previous update time. How about that? Previous update time. Update time. Okay. So, and here we need to say that we need to take the current time and current time. Okay, so that's the current time, and then we need to say that time elapsed, auto time elapsed equals to, it's the current time minus the previous time. What is the type? Okay. And now I need to get the seconds now. Now this is an interesting thing. How do I get the seconds? Gosh, I don't remember. Duration count. Is it like this? Yeah, I think it's like that. So it's a duration cast. How many nanoseconds we have? How many nanoseconds? Maybe I can take milliseconds here, right? Milliseconds. So milliseconds is, yeah, that's enough. So that's 1000. How many 1000 seconds? So then I need to just multiply that by 1000, right? Right? So time elapsed equals to, so double time elapsed equals to 1000 multiplied by the milliseconds. Okay. So I need to put it like that. Okay, so yips, current time, like that. And then I need to update the previous time. So the previous time will be yeah, I think I'm gonna do it here. Previous update time will be current time, like that. Yeah. Yips. Yeah, and now we're gonna pass the time elapsed into this function, like that. We're gonna update the ball with that time. Okay, so now the ball always goes the same amount of time. It goes with the time. It goes with the time. The ball is only looking at the time. So how can I test this now? Oh yeah, we need to just put the timer on. And what am I doing here? Begin. Okay, is that okay? So now I need to start the timer. Okay, I start the timer. And let's start the timer. I will do it. Where will I do it? That's a good question. Where will I do it? Maybe I can have a. I'll put the start button. Let me just do it like that. I'll put the start button there in the toolbar here. Let's quickly do this. Okay, I put T like start. Okay, T like start, right? Gosh. Edit, undo. How do I remove that? Undo. Yeah, something went wrong. Do it again. G like start. Like that, yeah. Okay. And now I'm gonna create the event handler for that. I'm gonna change the name. Button start. What am I doing? It should be S. That should be S, gosh. And now I need to, of course, and then I can do, yeah, like that, and then save, and I'm gonna put the S there. S like oh I need to change the color. Yeah, S like start. Again wrong. So difficult. S like start. Yeah, like that. Okay, doke. Yeah, and save. And then I go to I go to the wizard, class wizard. It was ID. What was that ID button? Yeah, that one. ID button start command. Go to the view. Then okay. So I'll start the timer here. Start. Okay. How do you timer? How is it? Start timer. Create timer. Course. What was the name? It's not timer. How can I forget? MFC start timer. Create timer. Set timer. Set timer course. Okay, so that's gonna be so I need to create the ID for that. I'm gonna create the ID const int. What was that? U and E. Set timer. U int BTR. U int BTR. And that's gonna be game timer. Game timer 1. So that's the timer. Game timer. Okay, so game timer 1, and then elapsed time. How often? Well, as often as possible. To be honest with you, as often as possible. So I'm gonna put 10 milliseconds. And then this can be null. Okay. That one starts the game. It starts hitting this. So here we need to check that if the timer is, if this is game timer, then we're gonna do this thing. Okay. So of course, is this gonna work or not? There must be some error here. Current time minus previous time. I need to push that on the next line. It's too much. Oh. Yeah. Current time minus previous time. Looks okay to me. Okay. Let us see what happens. This is very interesting. It should fluently go down now. It's just that the first time will be kind of wrong. Aha. Current time, because the previous time is wrong. Oh yeah, I need to set it here, sorry. So I need to, how do I do it? Maybe I can do it like this. So previous time is the current time here. Like that. Okay, so I start with the previous time is current time. And then I start the timer and then it goes here. Yeah. Okay. Moment of truth. Moment of truth. If I press this button, what happens? Moment of truth. I don't want to press this button, because then I know the truth. Okay, I will press the button. It disappeared. Okay, so let's see what happens. Obviously, I think we're gonna see the problem here straight away. So I'm gonna put the dot there. I did a mistake. So okay, so current time is like that. Elapsed time. Oh, that's way too much. That's way too much. So there's a mistake in the timing here. Oh gosh, man. I need to divide it by 1000. Gosh, man. it's not multiplied by 1000, it's divided by 1000. It's the opposite. Because this counter tells how many milliseconds, this is gonna be like 2000 milliseconds. So I need to divide it by 1000, not multiply it by 1000. So that needs to be so long. How can I make it shorter? Yeah, so count divided by 1000. Okay, how about now? Ha ha ha, there it goes. The ball is going down. But why is it not so fluent? I wonder. Why it's kind of going like a tuck, 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 tuck. I think it's just going because it's going so slow. It's just going pixel by pixel. Yeah, that's why. Because it's so slow, it's going pixel by pixel down. That's why, yeah. I just need to increase the speed, right? So let me increase the speed. The speed is this one, right? This is the speed. So, yeah, that's the speed. I think it's, well, not 10 times more, but that, let's say 4 times more. Let's put 20, 30 there. Compile. Okay, how about now? Press the button. Yeah, it's looking good. It's looking good. And now if I put a little bit more speed, 80. Oh, that's only double of the speed. Bouncing, not bouncing. How about doubling again? The ball needs to be a little bit smaller. No, it doesn't. No, the timer. It doesn't help. It doesn't really work. Starting the timer. It doesn't really. It only sets this one now to the. I think it's kind of messing up the whole thing. Actually, it's not meant to be like that. Of course, I can put it back there. I can put it back at the start position easily. Yeah, I can easily. Okay, so I can easily show you. I can easily show that we can easily change the direction and position. Direction, for example. Okay, so let me change the direction. Just to illustrate this, I think this is the last thing I'm gonna do. So I'm gonna add one more button, it's like a test button. Test button, okay. And okay, button test. And now I'm gonna project class wizard ID button test. So what's happening here? Okay. There it is. command. Okay, so I'm gonna test this. I'm gonna change the direction, for example. That's an interesting test. It's actually quite powerful. I can change the direction very easily now. So like this. So I say the ball set direction. Okay. And I don't need to care about how long is the vector. I can put anything here. I can put okay, so this is the x. Okay, so this is the x, so it means that okay, so the x is, how does it go? X minus goes left. Okay, so let's not go left, let's go right. And then I'm going up. So that means how much up? Well, let's go a lot up. Yeah, let's go a lot. I put here like 50, okay? So it goes very, very, no, directly up. Minus 50, sorry, minus 50. Okay, and then, yeah, it should be that easy. It should be that easy. You see, very good. You see, it continues exactly the same speed, and you can put any vector here. It doesn't matter. I can put here like, but if I put plus 50, it will go like, you know, like a flat. Oh, sorry. I need to put 0 here. I need to put, wait a second. Oh, it needs to be small. Yeah, it needs to be small, like 1. Yeah, so this, it goes to the right in a, just like a flat right. You see, it works very well. Yeah, it works exactly how I wanted. Yeah. So the speed doesn't change. It doesn't matter what values you put here. The speed doesn't change. I kind of like it. I was just curious if it would go twice as fast, since it doesn't check for the timer already being started. If you can register it twice. Oh, you mean if I press the start button? No, the start button is only initializing the previous time, which is, the previous time must have some kind of value, some kind of reasonable value. So the previous time needs to be the current time when we start. It would be wrong to put something else here. It's not logical to call this twice, actually, at this point, because the previous time must be the previous time, what really was the previous time. If we put a fake time here, it just messes up things. But of course I can change the speed easily. Okay, I saw you. Changing the speed is a piece of cake. So okay, let me double the speed, okay? I don't have the function here, do I? Oh, I removed that function. Funny, isn't it? I need to add that function, set speed, isn't it? Okay, so void set speed. I removed it. Why? Okay, I'll add it here, set speed. And okay, like that. And there's the get speed. Where's the get speed? Oh, we don't have a get speed. Okay, so I need to add that. Get speed. it's gonna be that one. Okay, so now we can double the speed easily now. So we have set speed and get speed. Okay, so now doubling the speed is piece of cake. So you just say set speed, and you put get speed multiplied by 2, isn't it? Get speed multiplied by 2, right? So it's doubling the speed, right? Okay, so let's see. I go up again, minus 30. I go up with very fast speed. Okay, I go up double speed. Okay, so let me change the ball size. By the way, the ball is too big. I'll change it to 70. So now it goes up double the speed. You see, it goes up double the speed. Okay, so I meant set timer call registering the timer. Pressing the button twice means timer updating it. Well, if you call the set timer twice, it just, I don't think it really changes anything. It just starts the timer again, which means that nothing really changes. It's you just get a little bit different start next time. It just starts the timer again, but nothing really changes if you start the timer again. It just continues running. Multiple, no, it's not about register. No, it's only one timer. It's only one timer. It's the same timer, and if you say set timer twice, it will just start that same timer again. No, it just start. It's like no, it doesn't change really anything. It's just the timer is just, you know, checking that click, and if you press the timer again, click, it starts again, click. So nothing changes. It's just that the next time when it comes here, it might come a little bit earlier here. That's the only thing what changes. No, it's not really a timer. It's not like a clock. This is not a clock. It's tick. It's a kind of tick thing. And yeah, I think it's in a good position. This thing now goes there, and then shoots to the skies. Yeah, I think it's time to. It's a long video already, so I'm gonna end here. I think I'm gonna continue this project soon, another stream. Okay, see you guys later. I need to go now, but I will continue actually this one probably. Continue this game. A good start, definitely. Okay, bye bye.